see. Okay. Now we're live.
Yeah. Hi, everybody. Nice to have you here in another one of our aligned streams.
Hello, everybody. So this time Arshey won't be around. He's traveling, so will be Boris, Dela, and me, talking a little bit about what's going on with Align, the CK ecosystem. So let's hope like you find this interesting. Where should we start? Maybe telling a bit about the CK benchmarks. So these are something that you want to talk about, Boris?
Yeah.
Yeah.
I mean, the idea was just to give some updates and talk about what we've been working on. I think the ZK benchmarks progress and efforts are probably interesting to a lot of people, and we're recording this so we can share this on YouTube afterwards and get some clips. I'm just sharing some links on Discord to let people know that we are live. So you guys go ahead, and I will get that organized.
All right. So yeah, we have been working on testing and benchmarking all of the CKVMs that already exist. Of course, there are many. You can run it in many different software, and each is very different. So we don't have all the configurations and all the options, but you can already see some tendencies. I'll try to share the link on the Twitter chat, so give me a second.
Yeah, there are several SDKVMs, and luckily, these last few weeks we've seen new VMs popping up. One that looks promising is the new version of the Nexus VM 3.0, where they did a redesign and changed the proving backend from their folding scheme based to STU. So that is something that is like super interesting to see.
So I think like Twitter or X is not working so good for me, so I cannot share the link. Like maybe Boris.
Let me try sharing.
But if not, it's ckbenchmarks.com, and there you will have all the information. We made public all the data. It all runs in like a Jupyter notebook, so you can do your own data analytics, change stuff if you want. Everything should be ready, easy to launch. You can see the configurations and make your own conclusions. What we notice about the other benchmarks is that all the teams were kind of saying like, hey, we are the fastest one. And of course, like not everybody can be the fastest one. So there might be things going on around. So we try to make some more neutral suite. We don't have a CKVM, so there are no incentives for us to show that one is better than another one. It's just what the data is. And we are trying to optimize all the provers as best as we can. So those are the numbers that show the best scenario. There might be some slight improvements to make because this is not very well documented in any VM, but you can kind of tune them to use more memory and go a bit faster. We try to play around with that a little bit, but we didn't see big changes. But you might be able to squeeze a little bit more of efficiency by fine-tuning the memory consumption. And since we are trying to optimize all the VMs, like the results that you're seeing should be quite fair. We enable every optimization that we see. That includes like AVX on CPU or Metal on the Macs. We don't have yet like the Apple Silicon benches, but if you have a Metal backend, it's fair to use it there is no reason to try to compare like a worse than optimal scenario for each prover. And as Leo said, like, yeah, we have many to add. We will probably do some open source collaboration thing where you can add more provers or more tests. Probably Arshay will come back with some news later. If you want to add something, like, you can add it, you can make a PR, everything is public. And we will continue adding provers, COSA Nexus, CISC from Polygon, Lita. I was thinking, well, we were thinking that maybe we could add a Snarkify, but it's not really CKVM. Maybe just to have some comparison. I don't know. What do you think? Dio, have you been checking Snarkify work?
Yeah, in fact, Snarkify during Iftenberg mentioned they were working on their GPU native CKVM, and according to the numbers they show, but we all know that everybody wants to say they are the fastest one. They were faster than SP1, and they mentioned that they already had like several plans to achieve real-time proving within the coming months. Everybody coincides so far that the main bottleneck right now is actually witness or trace generation. It takes more or less 80% of the time. So everybody's trying to be able to execute as fast as possible RISC-V, get like some checkpoints, and then build all the different traces in parallel. Okay, so that could be like something really interesting.
Yeah, all the provers that go really fast have that problem. So we will see if everybody reaches the stage that where they have that problem. The other thing that might be interesting is that I think Lita published that they are doing client-side proofs. So that kind of requires your prover to be bound in 1 GB of memory. So maybe that could be something interesting, like a test for low memory devices.
Yeah.
And one other thing of Snarkify, I think they don't have a general CKVM, it's an EVM. I mean, they are proving the EVM, at least the code that they see is the circuit for EVM. So we cannot compare like everything so straightforwardly, like, but we can at least do the benches where you prove like blocks of Ethereum. We didn't publish them yet, but they will be probably by the end of the day, at least the GPU ones. We need an upgrade on RISC-0 on the compiler. There are some details that are delaying those benches. But,
So Mauro, I'm curious to ask you about the benchmarks that you've been using so far to look at the ZKVMs. And maybe it would be good to even share your screen, or I can share my screen and show the ZK Benchmarks website. But if you're going to go through it, it's probably better if you are controlling it.
Yes, I can share it. So let me see. Well, I will try to share it. And I might have skill issues, but I will do my best. So, okay, there we go. So let me just in case to refresh it.
Okay.
So here we are doing like 3 main scenarios. One is a Fibonacci that it doesn't matter a lot of what computation it is. It's calculating Fibonacci's, but it could be anything. This gives you like a good measure of the native code execution speed or proving, because you don't have what SP1 called precompiles, or what RISC-0 call accelerators, or what other call built-ins or chips. Too many names, but specific circuits for things like Keccak. Then we measure Keccak, since it is one of the main bottlenecks on proving the EVM, and it gives you, and it's very useful for other applications. So it's a good way to measure something that is really important in real applications. And then we are doing the RSP, the red switching processor. This is mostly running the CK the EVM and proving some blocks of Ethereum. We might use something that is not RCP like for other applications, but for the time being, like this is like the most comfortable way to prove Ethereum blocks. Right now we have SP1, Pico, RIC0, and Pico. You won't be seeing like the Ethereum proofs here because we are uploading them. But yeah. Pico, we have like a full table. I can show it to you in a bit. Pico doesn't support GPUs, so we don't have that. So you will see like the machines we use, the benchmarks, the data, the raw data, and some plots. In this case, you can see like the Fibonacci performance. We are measuring 2 ways to configure SP1. Maybe we will change this a little bit. So you usually do a recursion of start proof. You have like 3 modes in all the provers. Okay, this is not explained here. We should add it. But you can use like a lot of proofs that are kind of linked, and then you end up with a very fast way to generate proof, but they become really heavy very fast. So then when you have so many proofs, you make them all one star proof. That's like the normal mode here. It is like the blue and the green line. And then you can do an additional step that is constant in time. Cost like it's always like 3 minutes or something like that. That is like the rapid to clock system. So you have like those 3 plots. And yeah, this is the time at the biggest sample. And then the same for Keccak. Well, in this one, you can see that for GPU, SP1 seems to be like the fastest one, unless your program is really small. If your program is small, RIC0 wins, but it loses over time. We have written like the rate of that data that you can hash per second. Okay, here we have it. So for example, you can do 80 kilobytes per second with SP1. I think this name is a little bit wrong now that I see it because it's not AVX. It's not very relevant that it is AVX because it's running on the CPU. It might be for something, but it's not very relevant. And the same for CPU. In CPU, we have Pico, and you can see that Pico behaves very close to SP1. It's faster. It's almost the same, to be honest, on Fibonacci. This is more than it could be a measurement error. It's just a couple of seconds. But in Keccak, it's quite faster. It's like 50% faster, and you can see it here. This is once again like the rates of the hashes that it can do per second. Hopefully this will be some very useful information for developers to pick the provers they like more. We will be adding support. This also helps us to decide which provers to add. Probably you will be interested in using in a line the ones that are faster. So we will be adding the fastest ones in the future. I can show you also the repo.
Yeah, I think that would be really helpful for people who maybe are interested in adding new tasks for benchmarking purposes, or I don't know, best settings for different provers, different ZKVMs. Oh, we lost Mauro.
Oh, we lost Mauro.
Maybe he will.
Well,
come back,
but
maybe closed by accident.
Yeah, no, but in the meantime, yeah, we have like lots of CKVMs, and people are really working towards removing several of the bottlenecks that we see. I think that part of the things that we saw in the graphs, that sometimes it is not entirely linear with the program size, is maybe because like some part of the program does not scale really well, is bottlenecked by some part. In some cases, it may be phrase generation. So of course, this is something we need to work on. The good thing is now we have like more options. There are also like some studies on evaluating the security of Poseidon, because really a good part of the proving speed comes from using CK-friendly hash functions. So this is something that then we should pay a lot more attention, because Poseidon is like a relatively new primitive compared to other things that have been around, such as SketchUp, for example. Yeah, now we have Mauro back.
Yeah, sorry about that. As I promised, skill issues. This is a repo. Everything is public. You have some data on the README. You have how to run it, the benchmarks, how to install everything in Ubuntu. In Debian is almost the same. So you can kind of copy paste this in a new machine and rerun the benchmarks. For GPU, you might need the GPU yourself, or like it doesn't work on both things like Pod AI or VAS AI, just in case. This is a limitation of FP1. SP1 took a decision that is to run everything on the GPU and the Docker, and it's really nice when it works. It's very nice in comparison to RIG0 that you have to install everything, but then again, sometimes it doesn't work. Then it's not so nice. And RIG0 works everywhere. But whatever, you have it here. I'm probably going to make this table, put this table in the repo. So this is like a page where we keep track of what we have and what we want to do. So you can pick some of the missing yellow spots and add the code for it. And then we will run it, but first we need the code. And let me show you a little bit how does it looks if you want to do if you want to process your data. You can just use a Jupyter notebook. I will show you that. It's going to require me to do a couple of presentations, but so I will share my. I have so many things open that sometimes it is hard to find them. So you should be seeing this. So in this case, I'm going to have an M with pandas. That's the only thing you need, and I do Jupyter notebook, and the name of the notebook is benchmarks. This is on the README, and this will open a Jupyter notebook, and now I'm going to show it to you.
We lost.
No,
we
yeah,
lost
yeah,
the
yeah. I have to swap it because I was sharing just that terminal, and now this should be open, and you can rerun everything if you want. Here you have the code. We removed the code from the site because it was like too much, data and information, and maybe you don't need it. Yeah, you can generate your own data. I don't know, like you can go here. Let's say like this is we have like, well, the amount of hashes per second, and you say, okay, but I want the percentage of how fast it is Pico against, I don't know, SP1. You can add a cell. This should be Where is it? If not, I'm going to use the Jupyter Lab one that I have been using. Okay. Now I have a cell, and I can do something like try to get the data for, I don't know, for Pico. I'm going to print it because I have it. I have already printed it, so this should be something like that. And I put it. Let me see how this is configured, but well, no, don't remember how this is indexed. Maybe here. No. Okay. Well, assuming that yeah, I can do it on the back while we talk about something and show you how to get more data. This is just the skill issues on Python. I need to check a little bit how we did this, but yeah. Any questions? Maybe Boris, Diego, or something?
No, I think it's pretty clear. It's something that you can go and play around. And also, if you want to support other prover or anything, as Mauro said, it should be possible to add everything. We just want to have like comprehensive benchmarks. Something that they also told me is that one of the expensive primitives is verifying elliptic curve digital signatures. So that is something that we could also at some point add. That is to say, what we want is to have like a realistic cost or time that is needed to prove Ethereum blocks containing different types of transactions to try to approximate the real computational power and everything for a typical block. But well, luckily, these people will keep improving their VMs so that we are closer to real-time proving, and then we can build other cool things. I don't know. It would be also nice if at some point we could use also other VMs. One VM that I really liked is Maiden VM, because with Maiden you can build things with privacy. It's really interesting. I think it was one of the best talks I went during ETH Denver. So it would be nice to have something like that.
Where was that talk given, Diego? Which event?
They gave several, but you had that D-Infra was a really good one. There was also one in L2 days. It was like really good. And then well, we have like some other news, but in the meantime, what we can do is well, we didn't have time to discuss this, I think, the previous one, but now we know that Buenos Aires is going to be the place for TechConnect. So
Yeah, you will be able to see us walking on the streets. Like, this is already happening for me. It's very confusing. Like, some days ago, I was walking through the streets, and some guy was like, "Hey, I know you from crypto." He was visiting Buenos Aires. We ended up drinking a coffee shop. So as long as we have time, like, you can stop us in the street. Well, we can show you the city a little bit.
Yeah,
we'll be neighbors.
Also, if you're watching and you're not already following Diego on Twitter, he is posting facts about Argentina and Buenos Aires every day leading up to DevConnect. So don't miss out on the great history knowledge and everything else.
No, it's going to be tough because it's like 200 days, which means I need like 200 facts, which of course I have, but the problem is like going fetching the instructions from memory. It's better if I had everything cached, but it's not always possible.
You need to do some pre-commutation on the weekend, like you write one for each day.
Yeah, maybe. So no, I think that is going to be excited because that will allow us people to see us uh, more easily. I think there will be lots of events also going on in Buenos Aires. Uh, and it's going to be easier, at least for Mauro and me, to be almost like everywhere because for the first time, I think we will not be traveling, and so we won't have jet lag or anything. And then we
And,
don't have jet lag when we come back. So it's
and
going to
very
be fun.
importantly, we already have mainnet because last time some people came from abroad, like we were building mainnet, and it's like really sad. It's like you are in the same city, but sorry, this when mainnet needs to be shipped. We cannot meet so many people. This time we should have more time.
Yeah. So I don't know. Maybe when RJ comes back and everything, we can continue discussing, or even like give some random information on Buenos Aires. So if you are thinking of whether or not coming to DevConnect, I don't know. You have more information. Of course, my opinion is you should definitely come. Buenos Aires in November has really nice weather, and there is a lot of food. Besides, if you love ice cream, it's kind of like the best place to be. Uh, so I
Ice
don't
cream,
know.
steak, and wine is what I keep hearing.
Yeah, I am not a big fan of wine, but
No, but it's very
it's
good, yeah.
That's what I keep hearing.
yeah,
Yeah,
but not
it's
cheese.
no.
Argentine cheese is not does not reach the level of French cheese. So then we had like some famous French people uh, making history in Argentina. Some of them were even officers in Napoleon's army. But well,
Interesting.
um,
Yeah.
yeah, no, it's quite crazy, quite crazy. When you start looking at the history of South America, it's a bit crazy. Um, I don't know if we have something else that you'd like to comment or something that we can discuss. Maybe there are like some questions or anything.
So I'm not seeing any questions in the chat, but I actually did want to just ask both of you a couple questions about the ZK VM benchmarking efforts, because I think I have a pretty good idea of why we're doing this and why it's important, but I thought it might be useful to kind of explicitly lay it out for people and explain why we care about benchmarking ZK VMs and how this fits into the bigger picture of what we're doing at Aligned.
Yeah, it helps Align and it's also a contribution to the community so that people get more involved in these kind of things. At the end of the day, we are supporting Ethereum. This is important for Ethereum. This is important for Align. As I said at the beginning, it's very useful to know like this kind of data to decide on which tool to use for building. Since we can support all the tools, this helps us guide our development and should help the users to pick what platform to work with while using Align. Right? So if one day one goes faster and then on the other day another one goes faster, you can change. Like it's not a lot of work. Things will still be useful in Align.
Cool.
I know, Diego, maybe you want to add something?
Yeah, no, it's just also to continue like help raise the bar in the industry. There are like lots of people like shilling what they are doing and everything. So we said, okay, let's try to make a comprehensive and kind of the most like neutral benchmark that we can. It's useful for many things. It's not only for Aligned. and to help us like prioritize or maybe choose some tools to do like proof aggregation. But also if you're thinking of building something or some application that we want to build on top of Aligned, it's useful then to know which VMs are maybe faster. On the other hand, we also learn how each of the VMs work, and even it's important to have information on the different VMs, because at some point you may want to use, for example, multi-proving. And so instead of generating the proof with one VM, you can generate it with two, and then you have to have both proofs pass. For example, it would be nice to have something like Nexus relying on Circle Starks and RISC-0, or with ordinary Starks, or some other proof system. It's useful.
Yeah, you can also, and you can also, well, we need to add the specific data, but having this data allows you, if you are building an application, to know, to have some intuition of the viability of your project. You can easily see how much latency you will have for proving something, and you can say maybe this is comparable to this, and how much it will cost. So it kind of closes up the loop. Like if you only look at a line, you see the verification cost, but you don't see the proving cost, of course. So with this, you can have all the data that you need to develop an application, or get your own. Maybe you need a benchmark of another thing, and you're very close to do it.
So yeah, I think that makes a lot of sense to me. A question that some people might have as a follow-up is, beyond submitting a pull request, say there's a specific type of proving task that somebody is interested in benchmarking, or some specific configuration of one of these ZK VMs. What is the best way to discuss this with you, Diego, other folks from the team, like beyond just submitting a pull request?
Well, usually open source is mostly like discussing things in issues. Like you can create an issue, you can open a discussion and submit a pull request. So that's how it usually works on open source projects. But we are also on X, so you can tag us there, or you can join these calls and ask questions, ask us.
We lost Mauro, and you lost me. I think it was a connect.
I froze. Yeah, whole
So,
platform glitch.
So either the open source mechanisms that are like just going to the GitHub, opening a discussion, opening an issue, and kind of things, or tagging us on X, or asking us in this conversation whatever you need. We can see it.
Awesome.
There's also like the Align Telegram, but I think it's probably more interesting to have it as an open conversation on X, actually.
Yeah. So if you're listening and you have thoughts on ZKVM benchmarking, we would love to hear what you're thinking and to see your contributions. Yeah, I don't have any more updates if you guys don't. I have one more sort of speculative technical question about the benchmarking that I would like to ask, just out of curiosity, which is, why do you think that RISC-0 seems to be faster when there's a lower number of parameters? Or I was looking at the Fibonacci, like, the number of, I don't know what the correct term is, cycles or numbers. And it seems like at these lower numbers, RISC-0 is performing better. It's faster than SP1 and Pico, but then when that number goes up, it slows down relative to them.
Because it parallelizes better at some points. Maybe in some cases you have a monolithic trace, and if the proof is like not very long, then it makes sense to have like a larger table and not having like different subtables. So it may be related to, for example, lookup arguments or things like that. It happens if you compare to what we had with our Stark prover. For some things, our Stark prover was way faster than other things, but it's a matter of how it scales when the problem becomes like bigger, and then the bottleneck shifts from one thing to the other. So that may very well explain why for smaller programs someone is faster and then it
Mhm.
breaks. It's a kind of non-linear.
Yeah, you don't see it on the plots because I think like most people don't care about the programs that small, but you have like a constant cost no matter the size of the program. And for some reason, like constant cost in ReZero is quite smaller. For SP1 is bigger. I'm not sure what that is. Like it will be like too much speculation for me like to
Yeah,
make a guess.
I was just
I need
curious
more
because
data.
I looking at the plots quickly, I noticed this kind of interesting relationship that was not linear. And yeah, cool. Thank you. I guess this really does highlight that the different ZKVMs may be best suited for certain use cases, and it's also why this kind of benchmarking is important.
Yeah, more or less. That is to say, speed is important when things are slow, but as soon as things start being like faster, other things will kick in. For example, uh, how easy it is to use it. For example, if you have like something that is like super fast and something that is not as fast but sufficiently fast and it's way easier to use, maybe then you're going to prioritize that. So right now, because everybody wants to reach something like real-time proving. Now, if you have real-time proving, it doesn't make much difference whether you run like. But well, I think we froze for a little bit.
Yeah.
Yeah. Maybe I can show you a little spoiler because we actually have the benchmark on CPU on red. So let me see if I have them.
Bit of alpha.
Yeah, a little bit of alpha. Okay, I have it, but it's raw data, so it's not too
Okay.
fun to see. I don't have plots.
People can see it on zkbenchmarks.com soon. So
you will be able to see it, but I will show you at least the numbers so you get an idea of how much are the current proving costs on. There we have it. It's like okay. They look a little bit high to me, but 35 minutes on SP1, almost 60 minutes, almost 90 on ReZero. This is proving on GPU RCP. The cost is usually linear with the amount of gas. This is something that you don't see on other benchmarks. We are doing a benchmark that covers more blocks, not the same as everyone is using it. And it's usually linear because usually the bigger blocks have more transactions. But you will see that some blocks cost less to prove, and it doesn't matter. It might be a bigger block in gas, and it might be cheaper because it has less ketchups or less transfers, and it's just like doing an operation out of time, and that's very efficient to prove. But it's going to be interesting.
Yeah, so I mean,
Yeah.
I've been looking at ethproofs.com, and it seems like with Succinct and Snarkify, they're getting 4.5 minutes on average to prove an Ethereum block, which is that's like an order of magnitude almost difference from what you saw on this GPU test.
Yeah, but it depends on the GPU you're using. Maybe they're using like bigger GPUs and then
this is not the fastest GPU on the market, the ones that we are using. So they might be using a fastest one.
At some point, I think we should do like a block where you have like 10 or 20 Groth16 proofs in one block. And so you have to do lots of pairings.
You want it to die, and the proof will die.
Nice. Yeah, I'm what did I want to say? Yeah, well, really interesting stuff and great work, Mauro. I'm excited to see the rest of the benchmarks, and I think a lot of people are as well. If you guys don't have anything else you wanted to go over today, we can wrap things up.
Yeah, no, totally. We missed RJ. Hope he arrives safe. And next week we can have like a talk also with him. He also has like several news to share, I think. And yeah, we've been discussing a lot the long-term roadmap of Aligned. We still have like several things that we want to build. But well, step by step, first we wanted to share these benchmarks. Yeah, we can continue talking about other things and also about Buenos Aires Dev Connect so that you get the technical and other things. It's way more fun. So thanks a lot, Boris, for joining us today. It was a huge pleasure, and thanks everybody for being here with us today. See you.
Yes, thank you, Diego, Mauro. Great seeing you guys. For everyone else, we're going to be doing these every Monday with the founders and core team members to talk about updates typically. So stay tuned. And on Wednesdays, we'll be doing community call type streams where we have friends, partners, other people coming on to talk about different topics and cool stuff happening in ZK and Ethereum. So stay tuned and see you next time.